What if I told you that right now, at this very moment, our solar system is surrounded by a massive shell of icy debris so enormous that it stretches nearly a quarter of the way to the nearest star? And here's the part that will genuinely mess with your head. We have never actually seen it directly. Not once. Everything we know about this place comes from objects that occasionally fall inward toward the sun, like cosmic breadcrumbs pointing back to a hidden kingdom we cannot reach. Welcome to the Oort Cloud. And trust me, by the time this video ends, your entire understanding of how big our solar system actually is will be completely shattered. Most people think the solar system ends somewhere around Neptune, or maybe at the edge of the Kuiper Belt. That is wrong. So beautifully, dramatically wrong. The Kuiper Belt extends from about 30 to 50 astronomical units from the Sun. One astronomical unit is the distance from Earth to the Sun, roughly 93 million miles. Sounds far, right? Hold on to that thought, because the Oort Cloud begins at approximately 2,000 astronomical units from the Sun and stretches all the way out to somewhere between 100,000 and 200,000 astronomical units. Let that number sit in your brain for a second. We are talking about a structure so mind-bendingly vast that light, traveling at 186,000 miles per second, would take more than 3 years just to cross it. Now here is where it gets really interesting. The Oort Cloud is not one region. It is divided into two distinct zones, and these two zones behave completely differently from one another, and that difference changes everything about how we understand comets, planetary formation, and even the long-term fate of our solar system. The inner Oort Cloud, sometimes called the Hills Cloud after astronomer Jack Hills, who proposed its existence in 1981, occupies the region from roughly 2,000 to 20,000 astronomical units from the Sun. This region is shaped more like a thick disk or torus rather than a perfect sphere. Scientists believe it contains billions, possibly trillions, of icy bodies. Because of its disk-like shape, it is relatively protected from the gravitational tugs of passing stars and the galactic tide, which is the gravitational influence of the Milky Way galaxy itself acting on our solar system. Objects here tend to stay put. They are gravitationally bound to our Sun in a more stable arrangement. But the outer Oort Cloud is a completely different story. Starting at around 20,000 astronomical units and extending outward to nearly 100,000 to 200,000 astronomical units, the outer Oort Cloud is a roughly spherical shell surrounding the entire solar system in every direction, above, below, and all around. This is the region that sends long-period comets screaming toward the inner solar system. When a passing star, a rogue planet, or the galactic tide disturbs the outer Oort Cloud, it nudges these icy bodies off their stable paths. Some get ejected into interstellar space forever. Others fall inward, making the long journey toward the Sun, which can take millions of years. When they finally arrive in our neighborhood, we see them as long-period comets with orbital periods exceeding 200 years, sometimes millions of years. Here is the controversy that scientists are still actively debating. Nobody has ever directly observed the Oort Cloud. Its existence is entirely inferred from the behavior and orbital patterns of long-period comets. Dutch astronomer Jan Oort proposed its existence in 1950 after noticing that comets seemed to arrive from all directions in the sky and from incredibly distant points in space. His math suggested a vast spherical reservoir had to exist out there. And yet, with all of our modern telescopes, including the James Webb Space Telescope and others, we still cannot see it. The objects are too small, too dark, and too far away. This means one of the most significant structures in our solar system remains entirely theoretical in terms of direct observation. Recent research from 2023 using improved simulation models has further refined estimates suggesting the total mass of the Oort Cloud could be anywhere from a few times to several times the mass of Earth, distributed across potentially trillions of individual icy objects. Some researchers even suggest that objects in the inner Oort Cloud may be remnants from the formation of the solar system itself, preserved like a deep-freeze fossil record of what our early solar neighborhood looked like 4.6 billion years ago. And here is the detail that genuinely gave me chills. The outer boundary of the Oort Cloud may actually overlap with the outer boundary of the influence zones of neighboring stars. Our nearest stellar neighbor, Proxima Centauri, is about 8,000 astronomical units away. The outer Oort cloud may reach halfway to that star. We are not as isolated in space as we think. Our solar system's gravitational fingerprint reaches into territory where other stars are already competing for influence. The idea of a clean boundary between our solar system and interstellar space is not clean at all. It is messy, dynamic, and constantly being disturbed. This is why the Oort cloud matters beyond just being a fascinating structure. It connects our solar system to the broader galaxy. It influences the frequency of comet impacts on Earth throughout geological history. It is a time capsule of solar system formation. And it sits right there, invisible, untouchable, stretching into the dark, waiting. If you are the kind of person who lies awake thinking about how impossibly large the universe is, you need to follow this channel right now, because we are just getting started with topics that will permanently expand how you see reality. Hit that follow button and never miss another mind-expanding journey. Now I have to ask you this. If the Oort cloud is only proven through indirect evidence, does that change how confident you feel about what we think we know about our own solar system? Drop your answer in the comments below.